Hey everyone, this is a video lesson for the changing the subject questions. This will be mainly focused on finding changing the subject when we are involved with powers and roots. Okay, first of all there's a quick starter, so please pause the video, complete this and then come back on for the answers. Right, the answers to these, the ones we've been doing more recently. First question here, x is on the right hand side, so I'll just move that over to the left hand side. And I'll need to then add 3 to both sides, so that x is equal to y plus 3 is my final answer. Now the next one is a bit trickier. If we recall right the way back to when we did SOHCAHTOA in class and we had our x, or a value we wanted to find, on the bottom of the fraction, we could do something called cross multiply. So that is where we take the x from the bottom of the fraction on one side of the equal sign and we can cross it over to the top of the fraction on the other side. We can do this as well with the 1, and that will then cross over up to the t. The result from that gives us t, for t times 1, is equal to 7x. Flip the side here then, again, so that x is on the left hand side. As I said before, this is not a necessary step, but I simply prefer that so that my subject is on the left. Lastly then, divide by 7 so that x is equal to t over 7. Next one here, we are doing all of the opposite actions to the questions we were doing at the very beginning of changing the subject topic. So normally we would add or subtract the number on the end and then divide by what was attached to our letter. Well, in this case we have to multiply. And that will leave us with x minus 2 is equal to 3b. Then we will have to add 2 to both sides. So x is equal to 3b add 2. Okay, so on to then today's work. We are looking at powers and roots, so questions similar to the ones that are currently on the screen. Now, with the ones that we did previously, we have always done the opposite action that has been applied to our letter. So in this case, we are trying to change the subject to x, which means we are looking to perform all of the opposite actions or the inverse functions for the things being applied to x. So in this case, in the case of A, we've got the square root of x. Now to undo a square root of something, we have to square both sides. Now when I square the square root of x, I get x, and that is equal to y squared. That's x on its own, therefore the subject of this formula is now x. That is the only step I have to do for this first one. For part B, there's a couple steps that I need to do. The first step though is to get rid of the square root, which would imply squaring both sides. Now that leaves me with x over k on the left. Since both of those things were underneath the square root, when I get rid of the square root, that's the only thing that changes. That disappears, everything else stays the same. Square on the right hand side leaves me with m squared. I'll just get rid of the wee 2's that I did for the working, just so that you don't get confused with what they are, if they're powers or not. Next thing then to do is to get rid of the k. Now x is being divided by k, so if we remove that to the other side, we have got to times m squared by k. Notice that the k is still not squared, the only thing squared here is the m term on the end. Now if we can square something to undo a square root, then we can square root to undo a square. So in these cases here, to imply that x is on its own here, we have to square root both sides. Now we've seen this when we did Pythagoras questions in class, so we've seen this process before. In this case then, x is equal to the square root of t, and that's us completed that one. A main thing to consider here is that we can only square root once our letter term has been isolated. So if I was to start square rooting here, I would be left with square root of 7, which is not what I'm after, in which case I'm just going to try and get rid of that 7 first. To do that, we divide both sides by 7. So x squared is equal to bm over 7. Now that the x squared is isolated, I can square root both sides. So x is equal to the square root of bm over 7. Okay. An important point to state while we're doing these questions is to make sure that if ever you have a square root symbol, it covers everything on the right hand side of your equation. Okay, you cannot have it too short or too narrow, otherwise it's simply not correct. It's not telling you it's a square root of bm over 7, it's the square root of bm or b over 7. Okay, make sure that square root is large enough to cover the whole expression. Okay, if it's too big, fine. If it's too small, that's not okay. So, part E, taking these together then into maybe questions that we've got to do a little bit extra. So in this case, I want to change the subject to the formula to R. First thing I'll do here is to swap the sides. Notice I haven't changed any of the order, I've just swapped over what side they are on. Next then, I have to get rid of the pi and the h. And I can do this in one step. Since both pi and h are multiplying the r, I can get rid of them by dividing by pi h. I can divide by everything that is multiplying my desired term. So that is r squared equals v over pi h. My r squared term is now isolated, so I can square root both sides, and I will be left with r equals the square root of v over pi h. Again, it's very important to make sure the square root covers your whole term on the right hand side. Lastly then, taking these together with a root problem. And the first thing I'm going to do here again is to swap the sides. Now x there is on the top of the fraction, so it means I won't have to multiply up or anything like that, so it can swap over the sides, no problem at all. So how do we undo a square root? We have got to square both sides. The t plus x all over 5 is all underneath the square root. So by squaring both sides, I end up with t plus x all over 5 equals n squared. Neither of my other terms, the t or the 5, has been squared because it was contained underneath the square root. The next step here is to multiply both sides by 5. And I'll just continue the calculations on the side. Therefore, t plus x equals 5n squared. Last step then is to remove the t, so we take that away since it's positive, and x is 5n squared, subtract t. Okay. There are questions for you to complete on this on the Teams page. There's also a little extension of the harder ones that are down the bottom there, if anyone manages to get onto them. Please let me know how you get on, and good luck with these questions. Thank you.